Have you ever pondered how we discovered something as infinitesimal and elusive as the electron? A question that might have crossed your mind, right? The electron, a subatomic particle that carries a negative electric charge, is one of the fundamental building blocks of matter. But it's so incredibly tiny, 1,000,000 times smaller than the smallest thing you can see with your naked eye. And of course, it's completely invisible. The challenge of studying something so minute and unseen is colossal. So, you might be left wondering, how did we even know where to start looking? Well, isn't it fascinating that the most profound discoveries often start with a simple curiosity? Certainly, the discovery of the electron was no different. To answer that, we delve into the annals of scientific history, where it all began with a curious phenomenon: static electricity. Did you know that the study of static electricity laid the foundation for the discovery of the electron? Yes, it's indeed a fact. It all ignited with a mere spark of curiosity. When the scientific exploration was still in its nascent stage, static electricity was an alluring enigma. The British scientist Michael Faraday, a pioneer in this field, conducted experiments. He played with magnets and electric currents in ways unimagined before. He used induction to generate electricity, faced the challenge of erratic results, yet pushed through. His breakthrough was the invention of the Faraday cage, a shield against static and non-static electric fields. He also delved into the baffling nature of cathode rays. These invisible rays, emitted when an electric current passed through a gas, were a puzzle to the scientific world. Faraday's experiments suggested that these rays were constituted of particles tinier than atoms. This was indeed a paradigm shift in scientific thought, whispering the existence of subatomic particles. Faraday's work had a significant impact, stirring intrigue and excitement in the scientific community. The baton was then passed to a diligent scientist named JJ Thomson. Thomson embraced this task, exploring these mysterious cathode rays further. He used the cathode ray tube in his experiments, subjected it to both magnetic and electric fields, and faced numerous setbacks due to the high degree of precision required. Despite this, Thomson's relentless efforts bore fruit when he discovered that the rays were made up of corpuscles, later renamed as electrons. This groundbreaking discovery earned him the Nobel Prize in Physics in 1906. Furthermore, Thomson's work on subatomic particles laid the groundwork for the development of quantum mechanics, greatly impacting future scientific strides. Thomson's and Faraday's work, their challenges and breakthroughs, heralded a new era of scientific exploration, pushing the boundaries of our understanding of the universe. So how did JJ Thomson finally uncover the existence of the elusive electron? Well, it began with his fascination with cathode rays. These were mysterious streams of particles that appeared when a high voltage was applied to a tube filled with low-pressure gas. Thomson decided to investigate these rays further. Through rigorous tests, he discovered that these particles were smaller than an atom, a revelation that defied the prevailing belief that atoms were the smallest particles in existence. Thomson didn't stop there. He went on to prove that these particles, which he called corpuscles, but we now know as electrons, carried a negative charge. This was groundbreaking, as it meant that atoms, long thought to be indivisible, were in fact composed of even smaller particles. These discoveries by Thomson were monumental, reshaping our understanding of atomic structure and paving the way for the development of quantum physics. And so, through centuries of curiosity, experimentation, and scientific rigor, we unveiled the existence of the electron, forever changing our understanding of the universe.